Hi, now we look into the chapter 3, application of the aerial photography. So we look into the aerial photogrammetry. So basically, for those who never heard about the photogrammetry, it is a technique to measure the objects 2D or 3D from the photograph, where it is imagery stored electronically, now is electronically through the CCD cameras or the radiation sensors such as scanners, where the results will be the coordinates of the required objects, topography, and also the thematic maps, as well the orthophoto. You might not ever heard this one, but for those who ever use drones to do the 3D modeling, the process of creating the 3D from the drone photos is actually called photogrammetry. So I will not really touch much about this because it's quite complicated, but it's good to know, for you guys to know that there are techniques that you can use to create the 3Ds that represents almost actual data on the surface, where it gives you a good data interpretations of how the surface looks like, and really helps in order for you guys to do the planning and monitoring as well. Okay, so basically there are a couple of the photogrammetries being used: far range and close range, right? So basically for the settings of the photos, we are using the far range photogrammetry, and also we're using the aerial photogrammetry or the terrestrial photogrammetry. But I will touch more into the aerial photogrammetry because most of the applications that are being used nowadays for the industry will be the aerial photogrammetry. However, for the terrestrial photogrammetry, for those who are interested to play around with the 3D printer, but you don't have money to buy the 3D scanner, because 3D scanner costs you about 80,000 ringgit. Yeah, you can use your phone camera with certain skills and certain techniques. You're able to generate the 3D data and can be rendered into the 3D images, and after that you can try to 3D print it. So this is one of the things that nowadays has been widely used, widely applied by the industry. And as we know that the camera also is very good, we can do that. Basically, there's a lot of tutorials in the YouTube you can look into, but it's good to know that these kind of things are real, so you can try to look for it. So basically, why when we do the aerial photogrammetry, right, missions is very important. You don't fly whatever times that you want, you fly on specific time. So during this time, we have to make sure that we need to fly specific during the noon time. Okay, and of course you have to look into the weather as well, and the scales, and some more, much more. And the sources of the aerial photo, it could be either you want to have the small scale or the large scale. It will affect on how high the platform of the aerial photo to be fly. If you want to have a small scale data, you can fly about 5,000 meters and above using your aeroplane. But if you want to have a large scale, using drone will be very helpful, because it can give you a very good data, very detailed data. Okay, and now we look into the digital data. So what are the digital data? So basically, when we talk about, especially in environmental remote sensing, so digital data being produced by instruments that systematically scan the portions of the Earth's surface as well as to record the electromagnetic radiations reflected or emitted from the individual patches of the ground. And these images will be represented in the digital forms, where those digital forms, it captures the brightness of the reflectance to form an array of digital numbers, or is also called as a brightness value. And those numbers for several spectral channels can be combined to produce the color images. So as we know that computer will not store any names, it's only store the figures. So this figures is basically a representations of the intensity of the reflectance. As you can see here, 0 black means no reflectance at all. The white one to 55 means the most reflectance over. So for the images in pixels, actually behind it there's numbers, and these numbers represents the intensity. And when those images, the intensity, the grayscale images being combined according to the sensors and according to these monitor representations, it will come out with the color. Example here, for the Landsat 5 data, band 1 is the blue, band 2 is the green, band 3 is the red one. Okay, you can see different intensity, different hue and saturation. When those three combined, it come out with the true color composition, which is the image that we are familiar with. However, by playing around with this band 2 green, band 3 red, band 4 is the infrared, it gives you a false color composition where it will highlight certain images, certain informations that have been captured by the infrared in here. In this case, the red one is infrared informations, where it gives you the moisture of the soil, the dampness of the soil, the water inside the soil. So the big advantage in using digital data, the numbers of the arrays in the image can be added, subtracted, multiplied, divided, and subjected to the statistical manipulations. Therefore, the digital representations can be increased to ability to examine, display, analyze. So it can do a lot of graphic or data enhancement, image enhancement on it, so that it can try to reveal most of the informations. Right? So in geodata, we have pixels, and they contains both spatial and spectral properties. Right? So basically, for the image in remote sensing is called raster data. So in raster data, every individual grid cells, they have their own data, only contain one number, and the data is very big. For your informations, one satellite images for size more or less about 100 by 100 kilometers square of the Landsat 8 is about 1 gigabyte of data. Okay, so energy will be reflected or emitted from an image seen is a continuous. Therefore, there's an infinite numbers of levels could be recorded. So digital sensors must able to detect such energy and convert the measurements into discrete levels. Therefore, radiometric resolutions refer to the sensitivity of the instruments or how many signal levels can be recorded by each pixels. So digital numbers, actually it depends on the capability of the instruments to either it is highly sensitive or intermediate sensitivity. So, and this also affects the radiometric resolution. And digital numbers are recorded in the pixels are the series of the binary digit known as bits, and radiometric resolutions determined by the number of bits available. Example here, 16 bits of instruments have higher radiometric resolution than 8 bits, where 16 bits instrument can sense more level of EMR. So the range of the intensity is higher than the 8-bit sensor. More data can be detected, more data can be analyzed by the computer and more. So these are the ranges. Normal camera only use 8-bit, but for remote sensing they uses 12 bits until 16 bit, and some of the hyperspectral data they are using 32 bits. So these are the variations, and you can see the difference between 8-bit and 16-bit. That's the differences, and it will also affect how good the data can be collected. Right? And now we look into the thematic interpretation. In thematic interpretation, aerial photos are required, where two quite different forms of interpretation are being used. The first one will be the thematic and also the photogrammetric. But here we talk about the thematic. So what's at the aim of the thematic is to use the relative brightness or colors plus partial pattern to map the distribution some aspect, such as soil or vegetation. However, for the photogrammetric is to use the relative geometric position to do the topography map making. There's two different things. So thematic interpretation is based on the subdivision of the photos into areas that are visually distinct, and such interpretations require some intelligent guesswork based on experience and the evidence. So if you remember that we discussed about the image interpretation. So in order to come up with this thematic interpretations, the the physical, or what we call is visual interpretations, image interpretations is a must. It's something that we can't really say it is scientific. It's more towards the arts. However, it depends on how wise the analysts do the analysis on the image. The experience, the exposures, the knowledge might affect or might influence the decisions made by the analyst. Okay, taking into here, this photograph can be divided into about 6 thematic classes. So each thematic classes is then interpreted in turn, and of course the ground truthing is essential to do the accurate interpretation, since many tones or textures can appear identical on the photograph. What are the ground truthing? Meaning to say, after you're done with the first thematic classes, you identify, you estimate it, you go to the ground, go to that particular point, you validate it. If it's same, it's good. If it's wrong, you have to go back and reanalyze it again. So it is important to visit an area if all possible in order to establish what the classes actually are in any particular case. So thematic classes can be defined using a variety of the features, and the principal requirements is that the classes must be consistent and related to the factors upon which the study is based, and the following can often be used to define the classes. Thematic classes, you can look into the photographic features. Example here, such as a relief pattern, where it suggests could be some erosion or subsidence or landslide. And then if the features shows the drainage style or density, so you can interpret as a maybe bedrock structures, soil or rock permeability, rainfall frequencies, tones, textures, give you some idea of the materials, surface runoff, vegetations, surface roughness, crop types, nature vegetations. It might give you some idea of the soil types, slopes, and land use as well. So when you try to look to do the classes, you can see the obvious differences between one to another, and you do some classifying here. Example here, cultivated ground and woodlands. As we see, it suggests that this one is an undisturbed area, and this one is the disturbed area where there are some human activities. So cultivated ground, when you go into deeper, you might able to see what kind of the activities being used here, and you can suggest what kind of the land use. The one is some built up areas, mixed farmland. Some of the image may show something like this. Example here is a mottling due to variable sediment type and more. It's geological aspect, sea, beach, ridges, mud flaps and more. Supposed to be like this and like this. And this is where you start to name it, and after that you will do the classification. And of course, the tone is determined both by the relativity of the subject and the strength and direction of the illumination. Thus, the tone of the area grounds appear different at different times of the year. Therefore, it is important for you to do the image processing techniques to answer the classes. And now we look into the classification of the land area. So, classification of the land area, land cover, classification. It goes to the physical appearance. Agro-Climatic, Agro-Ecological Classifications is a technical attributes like the soil profile, soil texture, climatic conditions, and the land use, the purpose of how the land being used. So most of us are familiar with land use because it shows the social economy, it shows the human activities, it shows the features, objects of on the earth and more. As opposed to land cover and agro-climatic, where it only shows some properties of the area without having association with the human activities, the population, development and more. And to measure land on its impact on ecosystem, therefore land use classification is required, right? And what are we using here in Malaysia? It is based on the land use by Anderson et al. Okay, so it's a land use is what people do on the landscape, where land cover defines the material on the land surface. So most of us usually we use the land use. And how basically remote sensing can be utilized to do the land use, land cover classifications. So the minimum area which can be classified is depend on the scale and resolution of the remote sensing images, and land use requires interpretation of more elements such as color, texture and more. And other data such as topo maps, road maps are utilized when detail beyond the capacity of remote sensing is needed. So after we do the classification and do the image interpretations, we can classify it based on this ninefold land use classification. However, in Malaysia, we don't have certain aspects, but we still can use it. And the spatial resolutions for the images of the satellite image also will affect the level of classifications. Okay, if you look here, level 1, 2, 3, it suggests that different kind of satellites will be used in order to help the analyst to classify the land use accurately. So now we can see how the classification levels based on the Anderson et al. Level 1 is the basic one, where it goes to the simplistic level, and after that it goes to the quite detailed one, agriculture and what kind of agriculture and so on. And the level 3 is the detailed one. It goes to what kind of the crops being planted, and I also will attach you with the Malaysia land use classification as being produced by this Department of the Town Planning, Rural and Town Planning. Okay. So what kind of field applications can be used by remote sensing? It's a lot actually: meteorology, hydrology, and more. So when we talk about SLUs, we talk about environment studies, we talk about hydrology, soil science, biology, and nature conservations, forestry, meaning to say, so almost all of it. While, maybe social science will not use it. Remember, physical plannings is where the social science will using it, because in development, by using remote sensing, you able to understand the land use, you able to understand the social economy of people, the population over the area. You can see how well the development on the area, the built up area, accessibility, and more. Historical places, and all of this will give the information about how the one community background informations, and also the explanations of the importance can associate with the importance of the land over the community, something like that. Thank you very much for listening.